So I've been told to get going. So this will be a session on free security resources that we think that your competitors are using. And it will be a lot about OWASP. I hope some of you are already familiar with OWASP, but if not, you will be by the end of this talk. Also, I have a lot of resources, and I'm a bit afraid that I'm going to run over time, so I'm just going to keep going until it's 22:02 and then break. And this session will naturally be available afterwards because there's also a lot of links as well that you can continue educating yourself in these types of resources. So my name is Johan Lindfors, and I work at a company called TruSec. TruSec is a cybersecurity company, and we work globally, but we are primarily in Sweden and the Nordic countries. And we have 10 domains working with different areas of cybersecurity. We are all from offensive, like doing red teams and pen tests and such, but we also have a threat intelligence domain, looking into sort of like what types of attacks are being continuously targeted against Ukraine for now, for instance. And I'm run the development domain, which means that I have 20 developers that are interested and really passionate about writing secure code. So we do that by long-term engagements, building software in a very mature fashion, meaning that we don't write as much code as we talk about and design secure systems. But we also help other clients with just educating them in how to behave differently, I guess, on what they've done earlier, and helping them grow their competence and awareness around activities that can help them become better at writing secure software. And another project that is interested in that is then OWASP. And OWASP stands for the Open Web Application Security Project. This is a non-profit organization, a foundation that actually have a lot of different projects and resources available for us as developers who want to become better at writing secure code. And there's a lot of community-led open source projects. Most of these projects that I'm going to show you is actually available with free source code as well, meaning that you can really not just leverage them, you can also contribute and send back to the community, which we think is really important. So we also think that OWASP is such an important project, so we also naturally sponsor them and are a silver partner, meaning that we can run events and we can talk about OWASP and such. And OWASP has mostly been famous for its top 10 list of vulnerabilities that exist, and I will naturally talk about that as well, because that's what usually people get introduced in. But I'm going to use this sort of like the governance perspective of where we are in our project cycle and how we do development. Usually we have this sort of like a waterfall methodology, even though we are using Agile or sprints or Kanban or whatever. And I'm going to bring up sort of like the TruSec top 10 list of top projects in OWASP based on this governance model. So I'm going to talk about some of the things that we can do, like for requirements and metrics and such, but also when we come into the design phase, implementation, verification. I don't have much in operations though. And OWASP has a couple of projects looking into the operations phase as well. But I think that one of the most important aspects of writing secure code is shifting left, meaning we want to make as much proactive work in this area because we want to avoid doing mistakes that will put us in a great jeopardy or sort of like have issues in operations. So if we can strengthen this area with activities, we will become more secure, but we can also become more efficient. Even though we are adding to the backlog or the log of things to do, we can actually become more efficient in the long run because we don't have to patch as much when it comes to the operations phase. So let's begin with OWASP top 10. How many are you familiar with OWASP top 10 list? Okay, most of you. So this is occasionally used sort of as a standard or specification saying that we adhere to the OWASP top 10 list, something like that, from a tools perspective or something like that. We consider this to be sort of an awareness document, and OWASP themselves have more or less claimed that this is the purpose of the document. Well, it's not a standard, it's more like a inspirational document on these are the top 10 vulnerabilities that exist and most critical security risks to web applications. And if you educate yourself in this area, you are also probably interested in so what type of vulnerabilities are there. So then you also need somewhat of a semantics or nomenclature for how you describe vulnerabilities. So one of them is a CVE, it's a common vulnerability and exposure. This is sort of like a specific vulnerability in a specific product. Sort of like the CVE 2022-3786 that was announced last week, the OpenSSL buffer overrun issue in X509 certificates. That is very specific to that version of OpenSSL. These CVEs can then be rated in sort of like a scoring system called CVSS. This means that if you have a CVE which has sort of low rating between like 1 or 3 or something like that, that is not that's critical as someone that has in the top 10 something. And it goes from 1 to 10. And so like the OpenSSL is currently positioned at a 7.5. It's actually ongoing. It's being still researched. But 7.5 is a high. It's not a critical. It was initially a critical, but then it got lowered to a high. So that's how you can measure and see, okay, how important is this CV compared to other CVs when it comes to these lists. And then CVEs can also be categorized into sort of a CWE, which is sort of a vulnerability type. This is a classification or a group of attacks that can happen against one specific technology or something like XML exploits or something like that. Also, if you are interested in lists of vulnerabilities, this is a list of vulnerabilities, because this is the OWASP top 10, which is pretty much the most famous one, but there's also the CVE top 25. They are actually most impactful than classes of vulnerabilities that you should really be aware of. So if you also are familiar with these, you probably might also have heard about MITRE ATT&CK, which is another list. And I realized that this is a really poorly done presentation, but I can't move this now. So if you are getting started with educating yourself in security, you should be aware of the OWASP top 10. But then you can become a bit more sophisticated. You should probably look into the CVE top 25. Then we really want to go deep down, you go for the MITRE ATT&CK, because then you're also talking about how attack vectors are used or attack actors and such are using that. So it's more like a threat actors. So OWASP top 10 has also been evolving. So the first one that was released was 2013, where injection attacks was the most important thing that people should be aware of. And then it became 2017. Injection attacks was still the top candidate. And now, or actually last year, the 2021 was released. And then it actually shifted a bit, because from injections, we actually now is looking at broken access control is the most important or the most critical vulnerability. So mapping this is not that nice, but it's still interesting to understand that the top 8 one here is actually based on data. So it's actually based on data in the community, and the last 2 one is actually community contributed. So we're more like not the data, but these are the topics that we should really educate our developers around. And they need to be understand about how to do secure logging and monitoring and such. But broken access control is the top one currently. So this actually means then for us as developers that we are doing something flawed when it comes to authorization. This is not authentication, it's more of what the rights or what permissions we get when we have been authenticated. And specifically then potentially by not verifying the rules or actually that we get applied to between calls and such. So this is a pretty common example. If we have an API or something like that with a get session or something like that, we can get call, we can say, I want to look at the user with user ID 12345. And if I look at this URL, I can kind of easily as an attacker identify like, if my ID is 12345, there's a high possibility that there's a user with 12346 instead. And if I can get access to that user's information, then that is a broken authorization because I can access resources that I'm not used to. So one mitigation for this is actually to say, let's use something better than an integer for the identification. It's harder to actually guess the next identity for this user. But the better one is potentially to combine like the call with sort of like the session token or something like that that says this is the rights, I only can get access to my information instead. And then I can't even, the identity is not interesting from an identity perspective. So this is sort of the problem then with authorization and getting access to this stuff. So if we're shifting from the the vulnerabilities into something called the OWASP proactive controls. This is another project that is really good. And this is more of helping us developers as how we should behave or skills that we need to become more aware and become more better at secure development. So it's not just the risks, it's actually techniques and controls we can leverage. But it's also mapped to the OWASP top 10. So this is the 2018 proactive controls, and it actually maps then, also not nice, but it's still a map, against these type of vulnerabilities or risks. That's a good thing, because then we can actually educate ourselves. If we have broken access control, we can easily find that there is actually enforced access controls. So how should we behave there? So then the proactive control says that these are things that you need to do, like design access control thoroughly up front. You should deny by default and such. So this is good practices for us to understand. And this is something that we can educate our users or developers about. We can also have like discussions, so we can actually focus on one area, saying, okay, how do we implement the principle of least privilege? What does that mean for us? And naturally, there's not just a headline, it's also like a documentation on what are the specific implementation details of writing software that has least privilege or isolation and such. So proactive controls you should really look into. And I mentioned also that OWASP top 10 was sometimes considered sort of like a standard or specification for how you can use tools and such to measure how insecure you are. But there is a standard actually that's called ASVS, or the Application Security Verification Standard. And this is a three-tiered specification or standard that you can actually say that my application will adhere to the level 2 of OWASP ASVS. That means that you have actually fulfilled a couple of requirements when you write the software. You can use this as a metric. You can say that this is what we are currently at, and we want to become potentially better, so we need what do we need to add to the implementation? Or we can also use it as procurement, saying that if we want to buy sort of like use a software from someone else, or use a web application that someone provides, we want them to be at least on level 2 or level 3, because that actually puts them to, they have to make sure that they can actually demonstrate that they are in that standard. There's also a mobile version as well if you're building mobile applications. So just sort of like the level of complexity that this actually means, because if you're on level 1 on ASVS, that's really simple. And when it comes to one-time passwords, one-time verifiers, this is just it's some of the topics in the specification, the 2.8.1 and 4 and 8, just to demonstrate the differences between the different levels. So if you are on level 1, meaning you just have the simplest web page, maybe you're not having any serious or information about people and personal details and such, you should at least verify that the time-based one-time passwords only have a defined lifetime before expiry. That is kind of easy to implement. The next one is, if you're on level 2, you also have to make sure that these OTPs can be used only once. It's okay, still kind of easy to implement. It's a bit more cumbersome. But if you want to adhere then to the level 3, you also have to ensure that the generation of these OTPs are actually based on the server system's time, not the client, because then you can do some interesting attacks if it's based on client's machine. So that's harder to implement, possibly. But this is also like the detail of these levels that you need to adhere to. A good thing about this is that if you think that this is complex and this is like, okay, how do we build this? OWASP has a project for that as well. It's called the Cheat Sheet series. And this is actually to understand that we as developers are kind of lazy, and that we have limited time of how we can educate ourselves in different tasks. So cheat sheets are pseudocode in very specific topics, which you can leverage then to become better at this specific implementation of one-time passwords, or how you do password resets and such. And then it will provide you with guidance, and you can also do that as an exercise and just have a sort of like a book circle or something like that. And we're going to read this chapter, and then we're going to talk about how we can implement this within our company, within our technology stack and such. And it maps also against all of the other things that we talked to. So there's like cheat sheet series of a document on how to protect against one of the top 10 vulnerabilities in OWASP top 10 and such. Once again, looking in authorization, these are like the highlights, the headers of the documentation for just authorization. And you can understand that, like, if you want to implement appropriate logging, then there's a section on how you do that with pseudocode and how you should actually architecture such a solution. Okay. OWASP also has a really cool project that I think is called, I think is really important, and that's the Software Assurance Maturity Model. And this is something that we usually use with clients to make them aware on their strengths and their weaknesses, and also what they should look into first if they want to become more better. So SAMM is actually 90 questions, sort of like a assessment that you do within the team or between teams or like across the company, and you answer questions on like how do we do security requirements or threat assessments or secure deployment or secure build. There's a couple of questions on there, and this says, okay, so when you've done all these interviews, the 90 questions, you get this nice diagram with just one of the colors, and you can say that, okay, we don't want to be this bad at defect management. We want to be a bit better. So then it also provides you with sort of like, then these activities that you can introduce into your developer process will help you become better. And you shouldn't focus on the numbers and saying we want to be on 2.3 or something like that. You should instead focus on the change and say that we want to make this adjustment. This will help you guide you in what activities should we add and what activities can we potentially postpone to later, because this will give us the best bang for the buck. Because there are no silver bullets when it comes to secure development. There's a lot of things that we need to do. So this is something we use, and a lot of clients ask us to help with, not just doing the interviews because they can do them themselves, but also then provide guidance on, okay, this is the map we are at, help us get better. Another thing that we also get asked about is when it comes to like securing the supply chain, like there's been a lot of attacks against the process, the build pipelines and such that we've had. And then there's another project called SALSA, or SLSA, which is run by Google and a lot of other companies, which is actually sort of like a standards and controls that it's not just an interview questions, it's sort of like 4 levels of requirements that you should do to become better at having a secure supply chain. So this is also a really cool project you can look into, and just going from like documenting the build stage of the pipeline, but then have a tamper resistance, making sure that you can have like builds that are signed, for instance, and such, and then going back to be a bit more resistant to very specific threats, and then have a high level of confidence. What's interesting, or kind of interesting understanding about SALSA, is that it's not transitive, meaning that if you have if you're using a package that says we are using SALSA level, we are at SALSA level 4, that doesn't mean that all of their transitive dependents have SALSA level 4 instead. Also, they can be at level 0, level 1, but it's just a better understanding of the code that you bring into the application, and specifically then from that supplier. Okay. I think you also might be familiar with the OWASP Use Shop, which is said to be probably the most modern and sophisticated insecure web application. This is something that we help or demonstrate to developers and demonstrate to teams of developers, introduce them to, and say that this is sort of like a worst practice web page, meaning there's a lot of flaws, and it's actually designed to have flaws So it means that it also has a scoring system and a scoreboard implemented in this. So when you identify vulnerabilities to the OWASP use job, you get like you get stars. So you get fireworks actually from the sides, and it's really cool. Then you can use this sort of like a capture the flag and say that you guys, we're gonna these guys, and let's find as many vulnerabilities as possible. And you can try to attack this web page then through SQL injections or cross-site scripting or different types of attacks. You can use tools as well. This is a really fun exercise and something good to do at hackathons and such. And it's also very cool because the use app is really flexible, meaning you can actually make adjustments to it and have a color scheme that fits your company. You can have other projects than just uses. You can sell something else like bikes or whatever. And I think it's really cool. They also have a Docker container for this, meaning you can actually pull this Docker container and run it on your system without having anything installed, actually. Meaning you're just going to attack a system which is isolated in a Docker container, which is sort of at least a bit comfortable when it comes to talking about security. It's really cool. And if you want to get introduced to attacking the OWASP use job, you should also probably look into the SED attack proxy or the OWASP SAP, which is a DAST or a dynamic application security tool that can help you with doing sort of a scripted attacks against use job or other systems as well. And this is fun. It helps you get you sort of started on types of attacks you can do. You shouldn't run this against any commercial websites or public-facing websites. You can run it against your own instead and try to identify vulnerabilities that you might have. And you can also introduce this or integrate this into your pipeline, making you can do this tests and such on the application so you don't have regression tests by having scripted attacks and such. It's also free, download. Available for multiple platforms as well. And if you want to become better at testing applications, OWASP has a project called the Web Security Testing Guide. This is a really thorough documentation on how to do web application testing. So that you can educate yourself in like different topics. Okay, when we want to become better at code reviews, this is the topic. This is the things that you should do, how you should gather people and what type of discussions you should have and how you look at code and stuff. This is also really good to have. The OWASP Top 10 also has an API version, meaning if you just want to write REST APIs and such, this is the project you should look into. These are like top 10 unique vulnerabilities against APIs. It's not the same as against web applications. There are absolutely some similarities, but there are some differences as well. And there's also a security cheat sheet for REST, which is really coordinated to this type of list. And it looks pretty much like this. On top, it's actually still authorization, getting access to objects through the API that you shouldn't have access to. And then it's like injection attacks and such, and then they also have rate limiting, kind of interesting naturally for REST APIs and stuff. So this is also a good project to look into. I don't know if you are really comfortable in your third-party dependencies, but you should, as a developer, be really familiar with what type of components you are using. This is something we also noticed that a lot of developers are bringing in a lot of third-party components into the applications without understanding the risks of these. It's not just being lazy, sometimes it's being productive, because we do know that features are a thing that is important for the business, and shipping is a feature too, naturally. So we can leverage third-party components by other developers, but what we don't usually do is look into what those developers have done or how they behave or how active are they when it comes to writing patches for security vulnerabilities and such, meaning we need to get a thorough understanding of not just the code that we write, but also the code that others write, that we bring into our solution, and then actually take responsibility and act upon if something happens with these dependencies. And there are actually a lot of tools to do this, like software composition analysis tools, and For instance, if you're a Microsoft developer, you can do .NET list vulnerabilities. You can actually look and see if the packages, .NET list packages / vulnerabilities, I think it is, you will actually get sort of like a list of vulnerable dependencies that you might have, and also a guidance and provided, say, you should upgrade this component, the log4net or something like that, to this version instead, and then you'll be safe at least. But you can also check the transitive dependencies. So if these dependencies have in the transitive dependencies, they will actually check the entire chain. This is something we really think that you should all start doing, because it's important to understand where all the code comes from. And there's a tool called OWASP Dependency Track, which is sort of a platform which actually looks at these dependencies and their transitive dependencies, and then looks at how are there any known vulnerabilities against these components. In that case, which is the version that has fixed these vulnerabilities, and how you should behave when it comes to those type of components. And you can also use this in your CI/CD environment. One thing that we also very often help clients with is threat modeling. And I don't know if everyone here is doing threat modeling. I don't think so, because that's usually the behavior we see. But threat modeling is actually a really fun exercise and a really valuable exercise when it comes to understanding the overall architecture of your solution, but also thinking more like an attacker or a pessimistic user or something like that. It gives, usually we do these sort of in very informal discussions where we actually draw with using different types of tools. The best is like still a whiteboard. It's good to have this in face-to-face environments with fika. It's always valuable in Sweden. And you just talk about code. You talk about the software design. So let's start with investigating our purchase flow in the applications, for instance. We can do this threat modeling like looking at data flows, how data flows from the user to the web application to the database and then back and such. And then we can just draw this in high levels. We talk about, okay, so between the database and the application layer, what type of transport protocols are we using there? What type of vulnerabilities, what type of attacks can we think about when it comes to how data flows? And then we immediately get an understanding of how we should actually mitigate those types of attacks by adding sort of mitigations like SSL, OpenSSL, or TLS, or something like that for transport and protect the information. So that's doing this from a data flow diagram. We can also do it with looking at resources, looking at like our database have very critical data. So what would happen if that data was stolen? So how should we protect that data, and how can we protect so that it doesn't get stolen? That's another perspective of doing threat modeling. We can also do it sort of from an adversary perspective, meaning like if we think as an attacker, if we understand how the malicious users are attacking web pages, if we can have that mindset, how would we attack our application? And with that negative thinking, we can have another perspective and see, okay, what mitigations should we have in the front end and on the APIs and so on. And if you do threat modeling, you probably want to do graphs. You probably want to have sort of like high-level perspectives like diagrams, maybe even written in code like C4 or something like that you can use to categorize and build these types of software descriptions. You can also use other tools like OWASP Threat Dragon, which is an open source threat modeling tool. You can download it. You can even use the source code on GitHub. You can install it on Mac and Windows and Linux, and you can just draw these type of diagrams that you can use. And then you can actually use different types of threats against this application. The tool will actually help you identify, based on different types of specifications. They can say, okay, from a confidentiality perspective, what are the threats against this system? And then you can document this, and you can save them in the source version control, and just get better when you continue to progress. There's also a threat model cookbook from OWASP that you should probably check into, like help you get started with threat modeling, because this is a very good exercise, not just from security perspective, but it's a good exercise to have amongst the developers just to teach yourselves around different aspects of the source code that you have and an understanding of the system, because that will help you become more redundant when it comes to if you lose resources or people leave and such. So it's a really good exercise. So OWASP Threat Dragon is a really fun, and also having this nice and cute dragon is a good thing. And this actually, if you noticed, I actually cranked it up to 11 here, because this is the 11th project in my top 10 list. So this is the Spinal Tap version of the good threat modeling. Yeah. There are some other projects as well. OWASP has a tool that can help you do checks on your third-party dependencies. It's called the OWASP Dependency Check. You should probably investigate that as well. If you can use that in your environment, that could help you become more aware. There's the code review guide. This is also really thorough and a kind of long document describing how a good code review process should look like and how you should talk with your developers about code. Not just focusing on bad code, occasionally also focusing on good code, like, for instance, patterns. So if we use patterns in our source code, when we try to teach our developers to use patterns, that will put us in a level of a trust of that. If we follow these patterns, that we also can use tools that verify that we are using the patterns, we immediately get more trustworthy, and we can trust the code a bit better than if we don't use patterns. So, and that's a good thing. Another good thing with using patterns and these types of behaviors is that you can actually teach developers to become more secure developers by not telling them it's about security. Because occasionally, security can become a bit cumbersome, saying that if you want to fix something that is security related, it's a bit more serious than if you want to fix something that might be like accessible related or user interface coloring or something like that. So if you instead can say that use these patterns, we can verify that you are using these patterns, you will become a better developer, and we will automatically get better at writing secure code. And I think that's a good practice to have. Sort of like domain-driven security, if you know about that perspective. It's like implementing patterns, like validation in constructors and such, making sure we're using domain primitives, different types of features of the languages and such. And this is something we can talk about when we do code reviews. So let's get together and then on a lunch, we bring in lunch, we talk about this code that is a really nice experiment or a nice example of how we should behave when we write code, and then look at something that is a bit worse and say that how can we change this together? And we do sort of like a mob programming exercise potentially, and we can change the behaviors from that perspective. So, and not blaming anyone. We never want to blame anyone when it comes to security, because then people will stop doing security altogether. Instead, we need to have sort of like a collective responsibility that this is something we do together. I think that is an important aspect of how we should look into this as well. There's also something called the OWASP DevSecOps maturity model, looking into, like we talked about SAMM, the software assurance maturity model. This is another maturity model. It's not as popular or as leveraged as the SAMM, but it's still something that if you are looking into like the DevSecOps pipelines and that aspects, this might be interesting as well, just to get an understanding of what type of activities can we use in our pipelines which can help us get better. It's actually currently run by a single guy. I think he has maybe some other contributors as well. It might be interesting to look into that, just to get an understanding of where we should become better. Then there's also a fun thing that's called OWASP Secure Coding Dojo, which is sort of like you get exercises on how to fix code. So you get flawed code, and you educate yourself in, okay, how should I fix this? And then I can move into the next exercise and then continue. So it's a really good thing of educating users, educating developers around this. So looking back at this governance model, or this 5-step processes, these are the areas we covered pretty much when it comes to resources available from OWASP or from others as well, like Salsa. And once again, I think it's important to investigate or invest time here. Some people say that shift left is the most important aspect. Others say that shift up is another aspect of this. And I think shifting up and shifting left, or shifting up is actually adding layers of security into the process. Meaning we shouldn't just do one thing. We can't just say we're going to use the use shop to educate ourselves in this time frame, because that doesn't really impact everything. And we should probably not only use ZAP for pen testing or something like that, but we can add these type of things that we will immediately become better, but we can also say that we're going to postpone we're going to introduce ZAP later on potentially instead, not just in the first step. And there's another project at OWASP. It's called the Application Security Wayfinder. It has another sort of like a process or the iterations of this process, and then it also says that well, in the design phase, you should do threat modeling. And these are the projects that OWASP has, and it's links to these projects. And you can say that if we want to become better in the design phase, we want to do threat modeling, we should look into the threat dragon or the threat modeling talks or some of the cool games that they have as well. So this is something you should also look into. And you can see it's kind of heavy when it comes to different projects. And these are actually just the flagship projects. These are the projects that are highly encouraged by OWASP to use. Then there are tons of other projects that hasn't really received the same attention, and they are also actively looking for contributions. So if you want to participate in this type of projects, you should really look into OWASP and give them some assistance. And they are really appreciative when it comes to that as well. And I am, I think, more surprised than you that I actually managed to finish this session in time, because I had 39 slides and I really didn't think that I would get past it. So if you think this was interesting and you want to learn more, you can visit our booth downstairs at the exhibit, or you can just send me an email at johan.lindfors@trusec.se. And I appreciate you taking the time. Thank you.